All right, so here is our next instructions that we want to understand. Now, to understand these instructions, we will try to understand the column 3 of our instruction set. Okay. To understand the column 3, we need to know a little bit of notation, because most of the things that we have in column 3 are given in some sort of mathematical form. So we have to understand some notations. For an example, if we have A, that means it's actually the content of accumulator A, meaning whatever you have in A at this point. Same is for B and D. X or IX means like index register, meaning the content of index register, which are 2 bytes itself. Y, same. Stack pointer, the content of stack pointer. CCR means the content of condition code register, which is 1 byte. EC, again, content of program counter register, which is 2 byte. M is a data, which is usually 1 byte. M:(m+1) means consecutive 2 bytes of data. Okay, consecutive 2 bytes. Basically, M is the first byte, M+1 is the next byte. Now, arrow signs mean copy. So if you understand these notations, you would be able to read what we have, what is mentioned in column 3, because the column 3 actually tells about the instruction, okay, in mathematical form. So it tells what the instruction will, meaning how the instruction will operate in mathematical form. So since we'll be exploring some additional instructions, so we need to understand these notations. Now let's look at some interesting examples here, which are beyond load and store instructions. Okay. Now let's say we are given the content of accumulator D, which is 10A5. This is given. Okay. Now at any point, this is what you know. Now what data are loaded into accumulator A by the following instruction. Now this time, you see this is a new instruction that we have in the instruction set, which is ADDD. And just by looking at the instruction, can you tell what is the addressing mode? Immediate, right? You can see there is a pound sign. So this means the data you are, I'm saying this is a data, right? 188, and that is also given in hex. Okay, now what is given? We are given the content of accumulator D. And remember, accumulator D is nothing but A followed by B, right? So that means you know this, that accumulator A holds 10 and the accumulator B holds A5, right? That is given. Now, what will be the operation? Because the instruction you are given is ADDD. Okay? How do I know what is the operation? We'll go to the instruction set and look at the column 3 for this instruction. Now if you go to this instruction, that's actually the first page. If you look at this instruction and column 3, you will see something like this. Now what exactly this means, if you understand the notation, you'll understand the meaning of this. Once you understand the meaning, it's actually very easy to apply. Now the meaning is D plus M:(m+1). Now that means that whatever you have in D, this D means the content of D, right, must be added with 2 bytes of data. This is 2 bytes of data. And once you are done with the addition, you will copy the data, meaning the sum, back to the D again. So basically all you are doing is whatever you have at this point at D, the accumulator D, you are adding something to it. That's what I'm saying. Now how do I know what it should be added? So I actually did the operation in the next under the action section here. So at this point we know what we have in D is 10A5, right? Because that was given to us. That's what we have in D. And the 2 byte of data is also given in the instruction. If you go back to the instruction, you will see the 2 byte data which is given in the instruction is 0188, right? That means that the instruction is something like you'll be adding these two, right? D and those memory location, the data. Now once you add these two, your sum would be 122D. Now this sum will be copied back to D according to the instruction. Okay? So basically what you are doing is you are just adding 0188 to the content you have in accumulator D. But once you are done with the addition, you again keep the sum in D. Okay? So what do you have in D right now after you are done with the addition? You have 122D, but be careful, D is just A followed by B. So if you look at the question back, the question was asking what you will have in accumulator A for this instruction. So you actually will have 1, 2, right? Because we just want to know what do you have in accumulator A, not the whole D. But you always have to calculate for D, and then you just have to find what do you have in A, or it might be B. I'm saying based on what the question is asking. Okay. Now, in this lecture, you will see that how we can apply the column 3. If we understand column 3, how we can understand the operation of the instruction. Okay. So, because in the column 3, most of the instructions you will see, we have the mathematical notation which tells that how the instruction will work. Any question here?
How did you get to the
So, yeah, look at the answer. It's 1, 2, 2D, right? So the first byte goes to A, second byte goes to B. Because the D is A and B, right? A followed by B.
Oh.
D always means A followed by B, right? So basically, if you have 1, 2, 2D, that means 1, 2 will go to accumulator A, and 2D will go to accumulator B. Because D is nothing but A followed by B. Any other question? Let's try another example. Now this time I have a pretty similar question, except the instruction is a little bit different this time. So what is the difference? The difference is the instruction right now is in direct mode, right?
Yeah.
And 188 is given in decimal. And this is also an address right now, right? Since it isn't, So basically, we are given still the same information, which means you have 10 in accumulator A and A5 in accumulator B. That is given in the question, right? And this instruction just add the data, 2 byte of data with the D, and you copy. Once you are done with the addition, you copy the sum back to D. Now, you know what do you have in the D, right? Which is given 10 A5. Now, how do you know what is the data? Because data is not given in the question this time. Because in the question, you are actually given an address. Because this is direct, right? Now, anytime if you have an address, you will always look for data into memory map. That's always, okay? Now, how do I look at memory map? So, I actually convert 188 to hex, because I always convert the data into hex if it is not in hex. Since 188 is given in decimal, I convert it back to hex. Once I convert it, I got BB, right? Or BC. BC, right? That's BC. So what I did is I looked at BC here. Do you see this green circle? So this is actually my BC. Okay? But I need 2 bytes, right? That's what I was told in the instruction. You see here is actually 2 byte of data. M plus 1, right? So I need to pull 2 byte. So that's why I actually pull 2 byte data starting from BC. Because the BC is the first address you are given. So you take the first byte from BC following the next byte from BD, which is this byte, right? So basically you will be pulling AFC9. And then all you have to do is what? Addition, right? So you will add AFC9 with 10A5, and then you will get a sum, new sum, C06E, and it will copy, once you are done with the summation, we'll copy it back to D. So now the D has a new content, right? After this summation addition, you have a new sum, so D has a new content. So accumulator A will have C0, and accumulator B will have 6E, right? Because whenever you have something in D, that automatically means that the first byte is going to accumulator A, and the second byte is the content of accumulator B. Because D, is just a combination of A followed by B. Any question? It is still the same thing, but the only difference is if your instruction is in different mode, meaning the direct mode or extended mode, you are given an address. So anytime you have an address, you always look at the data. Look for data in the memory map. Okay. Let's try another example here. This is a different instruction. So this time you are given the content of accumulator D, which is B01C. I'm saying is given, okay? That means that you have B0 in accumulator A and 1C in accumulator B. This is given, okay? Now, according to the instruction, if you look at the column 3, you will see D minus 2 byte of data, copy D. That means that this is a subtraction instruction, okay? That tells microprocessor to do a subtraction, meaning whatever you have in D, subtract the data from D and then copy the difference to D again. So if you look at the instruction, what is the addressing mode? Direct, right? Okay. And this is 91 is data, right? I'm saying is in decimal, right? So you have to convert it back to hex. Once you convert it, you pull 2 bytes from the memory location, right? How do you know this is what, 5B? Yeah. So if you convert 91 in hex, you'll get 5B. So I pull 2 bytes from 5B and following byte from, I'm saying 1 byte from 5B and the following byte is 5C. So you pull 2 bytes from here, which is 2389. Which will be my data, 2 byte data, which I'll be using to subtract from D. So once the subtraction is done, you get the difference, which is 8C93. Now this is the new content of D, which means the new content of accumulator A is 8C, and the new content of accumulator B is 93. The question was asking about accumulator B, so the answer should be 93.
So why do you subtract on this? How do you know we subtract? Yeah.
Oh, because the instruction tells the subtraction. Yeah, look at the column 3. That's what I'm standing. Look at the column 3 for this instruction. That's how I know, because it's D minus M colon M plus 1 is given there, because instruction always tells you what to do in column 3. Yes. So any instruction you are given, you will always first look at column 3 to understand what is the operation. If you know those, remember at the beginning we showed you a couple of notations. If you understand the notations, you'll pretty much understand what do you need to do for this instruction, okay? Which is mentioned in column 3. All right. Another example. This time you are given the content of a stack pointer, SP. Again, the stack pointer is a 2 byte register, so the content will be always 2 byte. So you are given 2 byte of 2 byte content here, which is 1ABC, right? This is given, okay? This is given in the question. Now, the instruction we have here is an inherent instruction. Do you see this instruction? Yeah. This is inherent. Why? There is no operand. TSY. Now, again, anytime we got an instruction, we look at column 3, right, of the instruction set. to understand the operation. If you look at the column 3 for this instruction, you will see this is what is written. SP plus 1 copy IY. What does it mean? This means that whatever you have in SP, meaning stack pointer, which is actually given to you, add 1 with that. And then after you add 1, copy that content to index register Y. So this is actually simple because you already know what you have in a stack pointer that is given in the question. You have to add just 1. Once you add 1, you will get a new content, 1A BD, but this content will be copied to index register Y. And that's exactly how it was mentioned in the instruction, right? So if you look at the question is asking what data are loaded into index register Y. Okay, so that means this is my index register Y, and the new content is 1A BD. That's what I just got, right? I'm saying it in the sum. So again, if we understand column 3, it helps us a lot to understand how the instruction will work. Any question here? All right, let's look at another example. So this time you are given the content of accumulator D, which is B01C. This is given, okay? Now again, the accumulator D means A followed by B, right? So that means we know that the content of accumulator A is B0 and the content of accumulator B is 1C. This is what is given, okay? The instruction here this time is ORAB. Now to understand the operation of this instruction, we look at the column 3, okay? We look at the column 3 of this of instruction set. If we look at column 3, this is what we got. B plus M arrow B. Now, some of the operator we are given in column 3 is a little bit tricky because you also should look for explanation of the instruction in column 2, because in the column 2 you are given a plain English description which is in short form, brief form. In the column 3 you are given the instruction in mathematical form, okay? Now this plus is actually a binary plus. Remember in the digital circuit class we used the plus as the binary OR, remember?
Yeah.
Now this plus is actually the binary OR. How do I know it? If we look at the instruction set and look at the column 2, the plain description, it actually tells a little bit about the instruction. If you look at that one, it actually tells OR accumulator, right? Do you see OR there in the column 2? Column 2. So you can always look at column 2 just to make sure what it is. I'm saying if you understand it. So this plus actually is a binary OR addition. So that means this is OR. This is not the regular, just traditional math addition. So the instruction said B, meaning the content of B, must be ORed with M. What is M? 1 byte data, right? And after you are done with the OR operation, you copy the data back to B, meaning the accumulator B. This is all about accumulator B, okay? Now if you look at the instruction, this is in direct mode, right? What is this here? Address, of course, right? Which is given in hex, which is, we don't have to convert it here. So this is given A1, so we look for the data here, A1, right? The green circle, that's my A1. Now once I know which is A1, which is 73, I can do my OR operation, right? Now you can do the OR operation in the calculator, but I still showed you the OR operation at the right side, that how you do the OR operation. Now you have 2 byte of 1 byte, first byte is 1C, so this is my 1C here, right? You see this is 1 and this is C, right? In binary. And the next byte is 73. So this is my 7 and this is my 3 here. Now remember, let's recall what the OR operation did. I'm saying what the OR operation do. OR operations gives you high when any or both inputs are high, right? Let's recall the OR gate. So that's exactly what's happening here. 0, 1. So if any of these is 1, it will be 1, right? You see here, all of these are 1s except the very leftmost one, because in the very left column, both of the inputs are 0, so the output is 0. Now this is my result, which is 7F. So the 7F is stored back to B, right, after this operation is done. Now the new content of B is 7F. Now this is the tricky part. If you look at the question, you were actually given the D, right? But the instruction only dealt with B, not the whole A and B. So basically, after you are done with this instruction, your A still remains B0 because nothing was changed in A. Because the instruction did not change anything in A. So your A is still B0. But the content of B is changed because of the instruction. Right? The content of B is changed to 7F. But the question was asking what will be the content of accumulator D, meaning the whole thing. So your answer should be B0 7F, even if B0 was not changed.
Yeah.
Say it again.
Yeah, it gave me A. If you do addition.
This one?
Is that what you're supposed to do? You're supposed to add B, so basically 1C plus 73.
Mm-hmm.
And it gave me AF.
Let's see. This is actually OR. Did you press OR? Meaning you first type 1C. Okay. Let me show you. Let me show you how to do it in the calculator. Okay. Because we have a calculator here. If you use this calculator, now here is my calculator. Now, if you use this calculator, you can do this operation easily. I wanted to make sure you understand it. That's why I showed it here. What you do is go to the view and then change the mode to programmer's mode. Now I have my calculator in programmer's mode. So what I'm going to do is I'll do an OR operation. So my first data is 1C. Oh, let's change it to hex. So that's why I'm saying in that case it will support all the hex digits. So let's do 1C, and then this is my OR operation. Do you see it here? So click OR, and then type 73, and then press equal. It will give you 7F. Now, we know that we can always use the calculator to get the answer, but I still wanted to show you why it is 7F and how it is related to the OR gate we have in the digital circuit class. Okay? That's why I showed you the bitwise OR operation at the very bottom right side, that how it becomes 7F. You see what I'm saying? This is just the OR gates in the digital circuit class. And in the hardware level, this bitwise OR is actually done using the OR gate. Because in the hardware, you just have those gates, right? The digital circuit, those gates. Now you can see how those gates are coming into play, because all those operations you are doing here are based on some combination of gates.
So with
operation.
This is always going to be OR gate?
This operation is always the OR. I'm saying this one, specifically this one, yes. And there are operations in the instruction set which will only involve AND gates, right? There are different types of instructions. See, in this lecture, we actually showed you only 5 examples. Now in the real quiz, you'll see some additional instructions. The purpose is, at this point, if you see any new instruction, you will always look at your instruction set, column 3 first. Also look at column 2, because column 2 there is a brief English description which doesn't tell all the details, but look at column 2 and column 3, especially column 3. Understand the notation so that you can do some operation. Okay? Now remember, this lecture is not only about the instructions we have shown you here. It's about most of the instructions we have there so that we can understand how to deal with the operation just based on the column 3. Okay? We are not covering every single instruction we have there, but these will cover a lot more instructions than, I'm saying, in addition to load and store instructions. Okay? So that's why we have 2 quizzes on these. But before I go to talk about the quiz, any question here up to this point? I hope we'll probably understand it better once we go to the quiz section. If you don't have any question, we probably will try 2 more quizzes for this lecture, quiz 5 and quiz 6. In both quizzes, you will be given instructions. Okay, so you might be given some new instructions which you have not seen here. Go to the instruction set, look at the column 3, and also try column 2 and do the operation. You can always use the calculator that we have to do the, the subtraction, addition, multiplication, division, and also those bitwise operation, A or and, exclusive or, exclusive not. I'm saying you can always try those as well. Okay. Let me stop this presentation so that you can try these quizzes, but make sure you finish these quizzes before we return next class. Okay, so that we understand the next lecture as well.